Here we have a trigonometry problem. That is, we have to evaluate the expression we have over here, this cosine of cotangent inverse of x. Okay, in my first step, what I'm going to do is I'm going to assign a new variable for this cotangent inverse of x. So let me assign theta equals to cotangent inverse of x. Okay, now I'm going to take a cotangent function on both sides of this equation. When I do so, I'm getting cotangent theta is equal to cotangent of cotangent inverse x. Okay, now on the left side, we can write this cotangent theta as it is. Okay, according to the property, so the cotangent of cotangent inverse of x equals to, so the stuff what we have here. So this expression equals to the stuff what we have here. So because cotangent of cotangent inverse will become just 1 times x is just x. So we get cotangent theta is equal to x. Okay, now I assume there is 1 in denominator over here. So we know that cotangent is a reciprocal of tangent. So according to Secato, what is the formula for tangent? So we know that tangent is equal to opposite over adjacent according to Secato. Since cotangent is the reciprocal of tangent, then what's the formula for cotangent? So just have to take reciprocal for this opposite over adjacent, then we'll be getting adjacent over opposite. So instead of adjacent, we have x. So this x can be considered as adjacent side. And instead of opposite, we have 1. So this 1 can be considered as opposite. Okay, now let me draw a right triangle over here. Let me draw it. Okay, so here I have drawn a right triangle, and here we have a right angle. And now let's consider the angle measure theta over here. So considering this angle measure theta, this is opposite side because this side is opposite to the angle measure theta. So this is opposite side, but instead of opposite side, we know that 1, so we can mark 1. And so this is the hypotenuse side, and because it's opposite to right angle, and this is the third side is the adjacent side. So for the adjacent side, we know the length it's x, so we can mark x over here. Okay, now we have to find the length of the hypotenuse to solve this problem. Okay, instead of hypotenuse, I just assume k as the length of the hypotenuse. Okay, now we can use Pythagorean theorem to get the value of k, which represents the hypotenuse. Okay, according to Pythagorean theorem, the square of the hypotenuse equals to sum of the squares of other two legs. Then I'm getting k square equals to x square positive 1 square. Then I'm getting k square equals to x square positive. The evaluation of this 1 square is just 1. Now to get up the square over here, I'm taking square root on both sides. When I do so, the square will cancel out. I'm getting k equals to square root of x square positive 1. So that is the length of the hypotenuse is square root of x square positive 1. Let me write it. Okay, now we know that all the three sides of this right triangle, and also now we can go to the original question, that is cosine. We have to evaluate cosine of cotangent inverse of x. Let me write this cosine over here. So for this cotangent inverse of x, we have assumed theta. So now we can plug in this theta for this cotangent inverse of x, and we get cosine theta. Okay, now let's evaluate the value of cosine theta in this triangle. So using Secato. So because here we have angle measure theta, here also we have angle measure theta. So according to Secato, the formula to find cosine theta is adjacent over hypotenuse. Let me write it. Adjacent over hypotenuse. Okay, so what is the length of the adjacent side? Adjacent side is x, already we know that. And what is the length of the hypotenuse? It's square root of x square positive 1. Now I have evaluated the value of the given trigonometric expression, that is equal to x over square root of x square positive 1.